Okay, شباب. The second set of transformations is the amplitude transformations. Okay, and similar to the time transformations, we have three amplitude transformations. The first one is amplitude reversal, then amplitude scaling, then amplitude shift. Okay, so we are going to take the easiest path by just describing these transformations by an example. Okay, so we'll take directly an example where we have a signal x of t. This signal you can take the shape something like this. Let's say this is, let's say, 2 volt and this is -1. Okay, this is let's say 3 in the time, and this is -2 in the time. Okay, and we want to plot, for example, we want to plot another function y of t, which is -3x of t plus -3x of t plus 2. Okay, anything. So this is just a general example. Okay, so that when you multiply the function by factor 3, this means you are scaling your function, you are scaling your signal, like similar to the amplification. When you use an amplifier in the electronics lab or something, then you are scaling your signal, you are amplifying your signal by factor 3. The negative sign here, it has many applications in practice, similar to the op-amp when you use the operational amplifier that you will study in the EE203 course, in the electronics course. You will find that many amplifiers, they reverse the signal. They are called inverting amplifier. Inverting amplifier means that it amplifies the signal and also reverses it. Okay, it inverts it. Okay, so the negative sign means that you are going to invert the signal in the amplitude x. Multiplying the signal by a factor means that you are going to amplify the signal by a factor 3, and then adding a constant to your signal. This means that you are going to shift the signal up or down. You are going to do a shift up or a shift down. Shift up if the constant is positive, shift down if the constant is negative. Okay? If you look carefully at this equation, you'll find that we didn't touch the time at all. That's why we call these transformations, we call it amplitude transformations. They are not time transformations because we didn't touch the time variable here. So in order to do that, usually we start with the multiplication. We start with the multiplication, we finish it, and then we add the constant. This is the easiest way to do that. So the first step that we will do, we can multiply x of t by 3, and then we multiply by negative. When we multiply x of t by 3, what will happen is the amplitude, it will be amplified. So all the amplitudes will be multiplied by 3, which means that this 2 volt will become 6 volt, right? And this -1 will become -3. Let's try to draw to scale a little bit. So this will be -3 volt. Did we change the time? Did the time change? No, the time didn't change because these are amplitude transformations. They are not time transformations, right? So this is after we multiplied x of t by 3. So this is the signal that results from multiplying x of t by 3. Then when we multiply 3x of t by a negative sign, what will happen is the amplitudes, they are going to be multiplied by negative. So instead of having 6 volt here, it will be -6 volt. So the signal is going to be reflected, okay, or mirrored around the x-axis. So what will happen is when we multiply by a negative sign, so -3x of t, we can plot it like this. This triangle is going to be reflected down. So it's going to look like this. This will be -6 volt, and this triangle is going to be reflected up. So we are going to get here 3 volt. The time didn't change, -2 and 3 here didn't change. That's it. So far we plotted -3 x of t. The last part is we need to add 2. We need to make a shift of 2. So when we shift the whole signal by 2, we are going to add 2 to the amplitude of the whole signal. So what will happen is, when we add 2 to this line, okay, it will go up. Instead of having 0 here, it will be 2, right? And this 3 will be 5. This 3 volt will be 5, okay? And then the same line here will appear like this. Instead of going to 0, it will be going to 2. Right? What about here? What about this part? This part was 0. So here, this part will be 2 because we added 2, right? So the whole part here shifted up by 2 volts. Like what about this part? This part will be also shifted up by 2 volts. So it will start, instead of 0, it will start from 2, and then instead of going to -6, it will go to -4. So at -4, it's going to appear something like this, and then it will go up again. Instead of going up to 0, it will go up to 2, and then this part was 0, and you are going to add 2 to it. So what you will get is, you will get something like this. So this is, in this example we applied, this is the function, the final function y of t. In this example we applied all the amplitude transformations, which are much easier than the time transformations, by the way. We applied the scaling, we multiplied by a factor here. Then we applied the reversal, we reversed it after multiplying by the negative sign, and then we applied the amplitude shift. It is possible, of course, to get both time transformations and amplitude transformations in the same example, and we will try to solve one example like this in the next video, inshallah. Okay, and in this case, if you get both of them, I prefer that you start first with the time transformations, finish the time transformations first, and then apply the amplitude transformations, and that's it for this part. Okay.